Hi, I'm Jeff Ranke, and welcome to 5 Minutes with Design and Development today. The decarbonization of the HVAC/R industry is on full display, with many manufacturers opting to showcase the increased efficiency of heating and cooling appliances and equipment. This is largely because legislators worldwide have set net zero targets for the carbon dioxide expelled into the atmosphere. Manufacturers are designing a new generation of heat exchangers with more advantages over present designs. These new heat exchangers have copper tubing designed with an even smaller diameter, probably around that 5mm range, than competing heat exchanger designs, allowing for a better performing product with higher internal and external heat transfer coefficients. To help us dive more deeply into this topic, I'm excited to bring Marcus Elmer, Director of Tube and Fittings with the Copper Development Association, into the conversation. He's responsible for identifying and influencing market trends, opportunities, and threats for copper tube and fitting products through the development and execution of strategic programs involving technical research, codes and standards, advocacy, and education. Marcus, thanks so much for joining us today. Starting things off here, maybe you can talk to us a little bit about some of the major benefits of these small diameter copper tubes that we're seeing used in heat exchangers a little bit more prominently now.
Sure. Yeah. Thanks, Jeff. Great to be here. With the transition to small diameter tube used, especially in heat exchangers, you're almost looking at quite a few benefits that come with that. One is the energy efficiency, and that's really reducing the diameter of the tube. It allows for less material, less refrigerant, more durability, and familiarity, and you're taking out weight also. So it provides the opportunity to reduce the weight of the equipment. It's having a small or less refrigerant. It's having a smaller or lower charge. And that really pertains and has its benefits that when you start thinking about higher pressure or temperatures, or even in today's world, as we start looking at newer refrigerants or natural refrigerants, having that smaller charge can provide a better and more safe environment for occupants.
You know, it's interesting when we talk about reducing materials, reducing costs, cutting weight. We see that in a lot of different areas. So it's interesting to see that kind of pop up here as well. Marcus, going a step further, why are you seeing a lot of the OEMs really showing this sudden interest in the small diameter copper tubes for ACR coils?
Yeah, so it really has to do with a few things. You start seeing a lot of paintbrushes on the canvas that's creating this landscape of really the next generation of HVACR equipment and heat exchangers. And it really kind of boils down to what is that carbon footprint, looking environmental impact, safety in the built environment. There was recently, or a couple of years ago, but we're starting to see more traction through that right now, is the American Innovation and Manufacturing Act, or the AIM Act, that was signed in 2020. And that's reducing HFCs, the production and consumption, over the next 15 years. And so what that does is provide the EPA the authority to govern the production, the release, the consumption of high GWP or global warming potential refrigerants that are really have the target is HFCs right now. And we also see new technologies, or the promotion and the opportunity to develop new technologies from the Department of Energy. They have recently are in the midst of running a cold climate heat pump challenge. And so with that new technology, the funding or the recognition from the DOE are these OEM and manufacturers looking at how can we provide high performing, energy efficient system heat pumps towards this shift to electrification.
Yeah, it's interesting. We sometimes hear about some of these trends that are focused on efficiency. Sometimes they're focused on the environmental benefits. It's really cool to see a convergence of both in this instance. Leading off of that, Marcus, what would you say the status of the development of some of this HVAC/R equipment with the small diameter copper tubes? Where is the development status in terms of with the OEMs?
So we are starting to see in the U.S. we are starting to see a slow transition to 7mm and 5mm adoption, and that really kind of comes with, as we previously talked about, the concept of miniaturization. So between safety, performance, health, with a smaller footprint in the equipment, or in the buildings, or in the space that's allocated for this equipment, is this movement to miniaturization. So it fits really nice in thinking of these packaged units from the OEM. And again, with the benefits that come with that, with the small diameter, it's the lighter weight and the ability to hold higher pressure. So if we think of CO2 as an option of natural refrigerants with these OEM. Having a smaller diameter tube performs well with these higher pressures. The smaller the surface area with that pressure can still continue to perform. And then the low refrigerant retard. Again, a natural refrigerant that we see out there that has gained some ground has been propane. So with the new, some of the new codes that are out there through ASHRAE or different other authorities having jurisdiction, there's requirements of low refrigerant charge that are flammable with these A2Ls or other mild flammable refrigerants. So with a smaller diameter, one of the options for these OEMs transitioning here is to help meet those codes in the building space. But there always come challenges as well with these small diameter sizes. Pressure drop is a concern with the smaller diameters as well. That can be overcome by reducing the run size. Again, back to that miniaturization concept. Another consideration really that we've seen OEMs adopt this to is taking into account the avoidance of freezing or having proper drainage through a defrost cycle. That's really overcome through some of the simulation software packages that are out there, showing the technology that's available by combining small diameter copper tube to fin with a copper aluminum fin, and showing the proper drainage in a defrost cycle to avoid that. So really a lot of benefits and transition to this next generation equipment really stems from a lot of broader factors as we look at energy efficiencies, global warming potentials, decarbonization, really that transition to the next generation of HVAC equipment and heat exchangers.
Awesome. A lot of great information there, Marcus. Really appreciate you joining us and going through all that. But that's going to wrap things up for today. For more information on the Copper Development Association, you can go to copper.org. For Marcus Elmer, I'm Jeff Ranke. We hope you've enjoyed this installment of 5 Minutes with Design and Development today.